No. This one. All right. So I'm not going to redo these. If you weren't here yesterday, you can just watch the video for that part. Did we do number 2? No. Okay. So the one on number 2 kind of troubles me because it's the basic idea of probability, actually percentage, is part out of whole, right? So how many people are left-handed in this room, or in this room in the problem?
20.
How many people are left-handed? 3 out of 20, right? So 3 over 20. And then the next thing that gets me a little bit down about this is that if I made you do this by hand, I have way too many people that do this. These are not the same thing. Are you guys cool with that? You guys see that?
Yeah.
This one is 20 over 3. This is 20 divided by 3, but this says 3 divided by 20. And I think more and more people are doing this because your brain is saying, 20 don't fit in 3. But of course, we understand that this answer is going to be less than 1. It's going to be much less than 1. Right? Now, what's a much better way to do this based off of what we did on that very first problem? Can I make the bottom become a better number for percentages? What number can I make the bottom become? 100. If it's out of 100, bam, I know what the percentage is. I'm looking at it, right? So multiply by. So what do I get? 15 out of 100, which is 15%. Kick ass. All right. Could you do long division, 20 into 3? Yes. Would you get the same answer? Yes. Would it take you longer? Yes. Okay, maybe. Yes.
Is that how you want us doing it? Like
Not
I
necessarily.
Did 3
Well,
equals x times 20, and then I divided by.
Oh yeah, sure. I love it.
Okay.
Yeah, I like it. But what I want you to see is if I just ask you for a percentage, you just make a ratio of part divided by a whole. This many out of this many. That is the basic idea of percentage. But I'm obviously not going to have any problem if you set up a beautiful equation. Holy shit. Right? Okay. But you don't have to in this case. All I wanted was a percentage from something where I knew everything. Blah, 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 blah. All right. So here we are in the second part. So I think I did some examples of this. And here's some more examples of this. Yeah, we did a few examples up on the board where these statements are just one step away from being equations. So if I said, what is 45% of 200, what would I put for what?
X.
Yeah, I don't know, so it's x is
equal for 0.45.
good. What does of mean?
Parentheses
Times
times 200.
200. All right. 90. Bam. Right, you guys get excited when you're allowed to use calculators. Why not?
Yeah.
So try to set up the equation for part B.
72.
No. I mean, don't say anything. Just try to set it up on your paper if you haven't done it yet. Just get a kick out of that. You can't see it. The focus says AF, so it's focus AF. You know what that means? You lead a better life than I do. 72 is what percent of 135? So how would I set that up? 72
Equal.
is, yeah, equals
X 150.
x of 135. I love it.
So, when you say of, it's multiple.
Yes. So in mathematics, this is another thing that's really big for me is people are coming out of high school not knowing what of means. It used to be an automatic. You just knew of meant multiply. And now they just aren't doing that for you anymore. Overall, generally. But of means multiply, for sure. Okay. And so now how do I figure out x? I just have to...
Equal X 150.
Say again? Sorry?
72 equals X 135.
That's what it says. How do I solve for x?
Divide.
Yes.
5
I say round to the thousandths
equals
place.
0.53.
0 point
53. 553. 53.
53 exactly.
No,
Can you again?
3.33.
533 rounded to the thousandths place. Is that what it is? I love you guys. Trying to crowdsource this thing. Are you guys okay out there? You guys have calculators, right? I didn't bring any, so hopefully you got some. I can get some really weird looks right now. Is everybody cool with what's happening up here? Kind of. Where have I lost you?
On everything.
Oh, okay. That's easy. The minute that I say something that doesn't make sense, you've got to stop me and ask a question, right? Say again, sorry. Yeah, there you go. Sweet. I love it. And what's it say to do?
How I know it's 533.
Round to the thousandths place, it says, right?
Okay.
Bam. What's the thousandths place? Tenths, hundredths, thousandths.
I got it.
So I've got to tell you, I try to remember to tell you to round it somewhere so people don't give me 18 decimal places just to cover their ass. All right, you guys, and what should that be written as? I really should go one more step. I think somebody else said this earlier. Yeah, I like it. Kick ass. Okay, get some shoulder shrugs. I like it. So how does this look as an equation? 2 equals, not x yet, 5%, 0.05 of what? Yeah. Right? 2 is 5% of times, I don't know, x. Do you guys see how that sets up? It sets itself up. It's one step away from being an equation. Maybe. And then you just have to do what? Divide by 0.05. X equals 40. Gas. Get this better over here. Come here. There we go. Sweet. Okay, how are we doing so far? Nothing too amazing yet. Shouldn't be. What about number 3?
Well, answer that,
Oh,
please.
sorry.
I'm still trying to.
So in the homework, there's quite a few problems like the next one. They don't necessarily say the tax on something. The similarity is this. They tell me the tax is $1,600, which is 8% of the cost of the car. So right there, I know this is an equation. It's already sort of 1,600 is 8%. 8%.
0.08.
0.08 of something I don't know. Yeah. Do you guys see that? So it's got more words in it, but it's basically the same as one of the problems we just did. 1,600 is 8% of something I don't know. Do you guys see that? If you can find this kind of an idea in a percentage problem, that's beautiful. You just got to set that equation up. Yes.
We cannot do x parentheses 0.08.
You can, of course, but it's convention to put the number first as a coefficient, yeah. But x times 0.08 means the same thing. And then, of course, I have to do what? Divide by, yeah. And then you get 20,000. I like it. Now, the last one is the hardest one on here.
Isn't it 20,000 minus 1,600?
No. Nope. What does x represent? Where did I put x? What does x represent? the cost of the car, right?
Okay.
So when I get X, I'm done. Because X represents the cost of the car. How much money did they have to pay before they could drive off the lot? 20,000 plus 1,600.
Okay, I did it the other way, where we finished it by saying 20,000 minus 1,600.
Oh, shite.
Okay.
Yep. Okay, maybe. All right, now look at this last one. The mistake people make, so just to cut you off before you start doing this, is they'll do 10% of 2002 and then subtract it. And that is not good. All right, it's not too bad yet. Should stop here. Let me say that again. So, how did I get to $2,002? Right. So there's a lot of I like the fact that in the homework there's problems that give you something very direct, which is not what algebra does. Algebra is always backwards. Here's a direct problem. If I have something that costs $50 and I'm the store owner, I buy it for $50. What am I going to do? I'm going to mark it up. Sort of like the bookstore here, right? Yeah. Yeah, they mark it up by like 35% or something insane. Welcome. So I bought it for $50. I'm going to mark it up by something so I can make money. That's probably the main reason I'm doing this. So let's say I mark it up by $10%. Right? How much would the new price be? How much am I actually going to sell it for then? You're going to sell it for $5? Wait, what's happening?
No, you add the 5.
Yes, where'd you get the 5 from?
Times point.
You did 10% of 50, right? I'm with you. But see, what's funny is you guys can kind of do this. All right, most of you guys are with this. If I wanted to mark up $50 by 10%, I got to take 10% of 50, and then of course that's just the amount that I have to add to 50 to mark it up, right? Okay, I like it. and then whatever the hell that is, $55. So, as I die in front of you, I apologize if I die in front of you.
I hope you don't die. We need you.
Well, that's nice. I'm glad somebody said something like it. All right.
You died to be passed?
No, I passed away. And then I don't know what the hell happens to you guys. All right, is everybody cool with this? Now watch. What is it that I don't know on the problem that I'm working on here? You're going to work for me, aren't you? We don't know what the original price of the laptop was. We don't know this amount. So the new price is $55 down here, right? You come on, stay with me. So the sale price is made up of the original price plus a markup. Where'd the 50 come from? That was the original price, right? So what if I didn't know what it was? So see up here. Oh, let me do it right here. Oh yeah, I can do it right here. I don't know how much the laptop costs, right? But I'm going to take whatever that is, the original cost is X. I'm going to add to it what? 10% of what? Of what it is, yeah. And that's going to get me to 2002. That's the thing people don't realize. They think, let me see. Let me ask you this here. I want to make sure you guys really get my point from earlier. So let's say that I make $10 an hour, right? Which is not horrible. Let's say I make $10 an hour, and I notice in my last paycheck that they cut my pay by 10%. Right? Just out of nowhere. So how much would I be making now? $9 an hour, right? Because 10% of 10 is 1. You got to subtract it off. I go and if I'm making $10 an hour and they cut my pay by 10%, 10% of 10 is 1. So that means, and then 10 minus 1 is 9. Now I'm making $9 an hour. So it's the opposite of marking it up. They cut me down, right? So everybody with me? I go complain and they say, oh, we're sorry. We'll increase your pay by 10%. Why am I still pissed? Did they bring me back up to normal? What's 10% of 9? 0.9, 90 cents. So they got me back up to 9.90, right? And when you're making so much money per hour, 10 cents is a big deal. It accumulates, right? Or I'm losing out on that. So 10% does not equal 10%. You really understand what I just said? 10% of what? So 10% by itself doesn't really tell me much. It doesn't tell me the amount I'm dealing with. So I can't do 10% of 2002 and subtract it, because how did I get to 2002? 10% of something that was less. Do you guys see what I'm saying? You can't see this kind of problem and just go, I just take 10% of this and subtract it. Because that's not what they added. They didn't add 10% of 2002. They added 10% of what it was before, which was less. So if you do that, you'll go too far down. Maybe, okay. So the real big thing is, the whole thing I just did back here, I gave myself a value for X, and then I saw what my brain did. And a lot of you guys were looking at me like, of course I could do this. I know some of you guys were like, what the hell just happened? But a lot of you guys were like, this is bullshit. But then you can't do this. And I understand because we have X's in there now, but the 50 is the thing I don't know now. So whatever I did to 50, I've got to do the same thing to X. Because they represent the same thing, the original cost. So maybe. So what would be the only difference in this equation if I said it was a discount of 10%? Then it would have been a minus right there, because I would have subtracted that much off, right? Now, the next step on this is, how the hell do you solve this? What is X plus 0.10X? Say again?
Plus 1.10. 1.
Oh, sure, it's 1.10. I got you. Because this is 1.00, right? So it's 1.10X.
Yes.
Equals 2002, and then how do I solve it?
Divide by 1.10.
Yeah, don't divide by the 2000 part.
No,
Yeah.
1.10.
And then whatever the hell that is.
1820.
1820? 1820?
I got this one. I don't know. I got this one.
You got 1820, okay. We'll go over that until somebody says something different.
Yeah, 15, yeah.
1820, okay. That was a good year. Bam. So put units on there, because I'm going to be an asshole and come in with pesos. So if you don't put units on your word problem answers, unless they're just numbers, you don't have to say number or something. If they're talking about number of dogs, if they're talking about money, if they're talking about whatever, you better put units on there. Or else I'm going to be an asshole and say light years, shoes, right? So this is bucks, of course, dollars. All right. Okay, so I kind of skipped over, now that some more people have come. Anybody have questions from homework, as I remember that I didn't ask that earlier? Any questions from homework stuff? Yes?
Number 35.
All right. Whew. Here we go. This one here?
Yes.
All right. So guys, look at 35 up here. This is chapter 3.
3.1.
Yeah.
35, yes.
One number is 5 more than another. So a few people have graded. A lot of people have done it fine, but some people are just skipping over the first step. So some people are doing this, x plus 5 plus 9 equals 60, but that's no good. So that's missing something. So what is the first step of this problem?
X
I
plus
forgot which
X.
one number is and what the other number.
Well, I haven't written for myself. Yeah. So what's the English of this problem? One number and
Another number.
another. So a few people are skipping this step, and sure, very often you can be fine with skipping this step, but very often it will screw you the hell up. Right? So which one is going to be just x? Yeah, it says one number is 5 more than another. So which one's just x? Another. And then the one number is 5 more than that.
X plus 5.
Good. And then it says, now this gets interesting. If their sum is increased by 9. So how do you write the sum of these two? X plus 5. That's the sum of those two numbers. If that's increased by 9, how do I increase this by 9? Plus 9, right? If I increase the sum of the numbers by 9, I get
Equals 60.
60. And then you solve it. Now, some people are stopping when you get x, you stop, but that's not good because how many parts of this make an answer? 2 parts. I need 2 things to make the answer. Yes?
I gotta put it like x plus 5 plus 9, like already on the one number thing.
Oh, but no.
No.
Nope.
But I got the same.
No, you didn't.
I got
It,
16.
no. What are your answers? The answers are the 2 numbers.
37 and 23.
See, that's a problem. All right. Because you're going to, I really want you to see this. When does the 9 come in?
At the end.
Afterwards, after I've defined what the 2 numbers are. So neither number has 9 in it. Right? One number is 5 more than the other. That's all they've given me as a definition. And then I'm going to add on top of their sum 9. So that's not a part of either one. Now, I really want this to make sense. If you did this, if you put a plus 9 here and you set the equation up like this, of course you're going to get 2 numbers that make 60. I really want you to understand this. Of course your 2 numbers are going to make 60. It's just that the 2 numbers you got are wrong. They're wrong parts of 60. Does that make sense?
Yeah.
Why are you definitely going to get 60? Because you made your equation come out to 60. So whatever you get is going to make 60 because you forced it to. Okay, maybe. So sometimes word problems are a little evil because you can get the right answer, but the parts are wrong because you've mixed things around. So what happens very often is there's something that says, let me find one that says this. Blah, 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 blah. Yeah, well, shit. It doesn't really matter, Jeff. Like it'll say one number is 8 less than twice another, right? It might say one number is 8 less than twice another. So I'll have this kind of thing. That makes no sense. If you write down something and nothing is just x, you have more than likely made a mistake. It never said that one number is 8 less than something and another number is twice something. It never said that. That's what that says. That can't be. So if I said one number is 8 less than twice another, well, the other one's x, and this one would be 8 less than twice that. So you can't let things float around between the two. They are each distinctly defined. One is just x, and then the other one builds on that. That almost always is the way things work. Okay, maybe. Yes?
I have a question about the odd and even integers, because I was with a tutor and she was telling me that what it is, because we went through it before, it was like x plus 2 would be is an odd integer or is it an even integer?
All right, that's a weird question. My question is yes, no, I have no idea how to answer the question. So right now, watch. Can you tell me if these are odd or even? You have no idea. It depends on what x is. If x is even, those are all even. If x is odd, those are all odd. So these represent a set of 3 even numbers. They also represent a set of 3 odd numbers.
So it could be x plus 1 or x plus 2.
Hell no. Why? Because write down some odd numbers. Give me some odd numbers. 3, 5, 7. No, keep going, sorry. How far apart are they from each other? 2 apart. So I understand your brain says 2 and 4 are even, Jeff. How the shit can they be parts of an odd number? It's not the numbers, it's the pattern. How do you get from one odd number to the next odd number? You add 2. How do you get from one even number to the next? You add 2. Do you understand what I'm saying? This is not the numbers. This is the pattern between the numbers. Does that make sense? So don't say, oh, there's a 2. I must be wrong. That's an even number. No, it's just how far apart they
I
are.
was listening to what you were saying, but the tutor, I think, was confused on how I was saying it at all.
Okay, maybe. I don't know. Okay. All right.
Because she was kind of looking at me like, yeah, it's like slow. That's how you were explaining it to me.
But no, I understand how it's confusing. I totally do, because like I just said, you see 2 and 4, and you're like, how could that be in a problem that's talking about odd numbers, right? But do you guys see that that is not the number 2? That is 2 things that are 2 apart. Huh? Everything good?
Yeah.
Okay. Anything else from homework stuff? Yes.
170.
Did he pass?
Yeah, it starts at 343, I think.
Thank you. All right. Yay. Ivan has $8.75 in nickels and quarters. Ooh. All right. So this is kind of a relatively nicer one, but it's got some weirdness in it. What are the 2 parts? I kind of gave it away. There's 2 things here, right? There's 2 players. What are they? Yeah, the number of nickels and the number of quarters. And I really, really wish people would understand and do this. This isn't extra work. This is totally helping. This is helping you realize that you have to look through a word problem a couple times. There's nobody in the universe that says you must be able to go straight from reading it once to the equation. That is insanity. My God. So, which one is going to be just x? The number of nickels is twice the number of quarters. Quarters must be just x because the number of nickels is twice that. And since I call this x, I can now call this one 2x. All right, and then they've got $8.75 total. This feels very much like a couple we did yesterday. Every nickel gives me how much money? Now this is interesting. This is where you got to be careful. Every nickel gives me 5 cents, right? Is this money written in terms of cents? No. You can write it in terms of how many cents is $8.75? 875 cents. And I would much rather do that because otherwise you need 0.05 times 2x. Right? Isn't 0.05 the dollar amount of a nickel? Does everybody understand that? That's the thing that the bowling alley doesn't understand at the bottom of Fletcher Hill. Fletcher Park. You know what the bowling alley I'm talking about? And it says 0.99 cents. I'm like, I want to go in there and plop a penny down and go. Because 0.99 cents is not even a full penny. I'd plop a penny down. I'd say, you don't have to give me change. 0.01 cents. You can keep that. And I'm going to go play some bowling. That works. Whatever. Sorry. So every nickel gives me 5 cents. Is that cool? We did this kind of thing yesterday. 5 cents for every nickel. And every quarter gives me 25 cents for every quarter. And so altogether that gives me 875 cents. No decimals to worry about if you make everything cents. Do you guys see that? The big mistake is if you have 5 and 25 and then 8.75. No, it's not going to work.
That's what I was doing.
You have to have the units match. Okay.
But it doesn't matter. If you
Yeah, you either can make it like you. Oh wow. You either can make it like that, or you can make it like this. 0.05 times 2x plus 0.25 times x equals 8.75. These are equivalent equations. Yes.
So you could just move the decimal over and make it.
Yeah. If I multiply everything by 100, do you see how it makes all the decimals over twice? So this equation would become this equation, Or you could just start here. That's what I really love. When you have something equation, algebra-wise, you do, and it actually makes physical sense. I just made it into sense. It killed the decimals, and then you just made it into sense, which is where you could have started. Okay, maybe. Okay. Anything else from homework? How much time do I got? I love Wednesdays. They're crazy.
15 minutes.
Yeah. Thanks. I just want somebody to go, now it's 10. Come on, math boy. Step it up. All right. So let me see. Maybe, yeah, let's do this. All right. I think I want you specifically. Let's do this in a weird way. I want you guys to do number 6 on this thing first. Look on the back, the bottom, the very last problem on the sheet. Let's do number 6 first. That's the percentage problem. So this one about the price of a computer. Oh? 4,000 what? Dollars. Is that how much they? Oh, a desktop.
Yeah.
Oh. Did it come out to be 4,000? Oh.
No, I was just saying. The other thing was really close.
Oh, okay.
Going
Dude, it's amazing. I still remember. I don't even want to tell you. I don't come from the days of the vacuum tube computers that filled up a room, thankfully. If any of you think that I'm that old, but I come from the days when 64 megabytes was a huge amount of memory and 266 megahertz speed was like amazing. So if you know anything about computers, that's
A Commodore?
Commodore 64, man. I had me a Commodore 64. So number 6, it's not as difficult as the one we did together earlier. It's not supposed to be.